Hello and welcome back to the Cloud Chronicles. We're nearly at the end of this marathon networking session. There's a lot of stuff here. Hopefully, if you've been watching these, you're ready to take AZ700. John and I wanted to wrap up with a talk on Azure Network Troubleshooting because it's a little bit different than the rest of normal network troubleshooting, a little bit. I'm Joey Dantoni. I'm Principal Cloud Architect at 3Cloud. John, go ahead.
I'm John Morehouse. I'm a principal consultant with Dantoni and Associates. And
So,
let's do some troubleshooting.
Yeah, one of the things that's kind of interesting about network troubleshooting in Azure, and in where things get really different, is if we were just kind of talking through this in pre-show. If you're in VMs, you can use a lot of the same tools you use. And wait, my screen's not flashing. I think I actually have to click something.
Oh, there you go. Isn't that cool?
Yeah, now we get flashing. Now it's working. That's how you can tell. So if you're not new to network, if you're new to networking and you haven't worked in a data center before, you will know all of those flashing green lights are a good thing. What do you not want to see there, John?
Red, I think.
Red or orange. I think orange is
orange.
degraded. But when you're in a data center, you can literally see the network switch and you can see if it's got a connection. You don't get to see any of that in Azure.
No.
So let's talk about this. I think for the most part, it just works. We've talked a lot about networking. We've talked about peering. Things most of the time just work. It gets complicated at times, though. You want to talk about some scenarios where you've had connectivity issues?
Well, I got to think about a couple. Sometimes it's DNS. Sometimes DNS can get wonky if you're using a mix of your own DNS and Azure DNS and strange situations. We talked about private endpoints, or I've had issues with private endpoints not working correctly. I've had route tables be wrong, and we had to change route tables to route traffic to the appropriate appliance or direction.
Yeah.
So sometimes sometimes it can pull your hair out, Rich. I don't have any left, so.
I think the most common one I've run into, and you see this a lot in enterprises where you have third-party equipment, is you have user-defined routes that get a third-party equipment, and that kind of becomes a black box, and it's hard to capture things within there. It also tends to be problematic about if you have like PaaS resources, and if you have like a PaaS resource connecting to a PaaS resource. Because you can't shell into any of those things. John and I were just talking about our favorite network troubleshooting tool, which is the PowerShell tool, Test Network Connection. If you don't know, it's a great tool. There's also a built-in PowerShell alias in Windows called TNC. So to use Test Network Connection, you can just type TNC, the host name you want to connect to, and then -port. Unfortunately, for those of you who aren't on Windows, even if you're using open source PowerShell on Linux or Mac OS, testnet connection has some dependency. Nobody's ever explained this to me, and it's really strange, but it has a dependency on WinForms. So it doesn't work in open source PowerShell. I think there's a test-connection commandlet, but mainly if I'm on Linux or Mac OS, I just use Telnet client. It's not as good as, it doesn't give you like connection stats like testnet connection does, but you can see if a connection went through. Anything else you use, like from a command line perspective, John?
Testnet connection is very prevalent. I use traceroute if I'm on a Windows box, just to trace the next hop, which we can do in Azure, and I think we'll get to it eventually.
And sometimes that works, sometimes it doesn't, because one of the things that is kind of important to understand is ping and traceroute use a protocol called IDMP. I hope I got that right.
I think you got it right.
And that protocol is not always enabled for everything in the cloud. So like sometimes you can ping, like yesterday, or we were recording a video on using private link in Azure, and we kind of broke some things. And and we were trying to ping something, and we know ping's never actually going to respond, but one of the things you look at to isolate a DNS problem is you might want to see if ping resolves the DNS address. So if ping gives you a proper IP address, then you can at least assume maybe that DNS is working correctly. Traceroute's kind of the same way. Like maybe you'll get the first couple of hops that are within your network, but it might not show you everything that's going on the Azure backbone network. Yeah. One of the things that's kind of interesting is like the way routing works in Azure is depending on what you're connecting to, and in some cases how you've chosen, because sometimes they'll give you the option if you want to stay on the Azure backbone or if you want to go over the public internet. You may leave the Microsoft backbone network. You may stay on the Microsoft backbone network for communications to happen. So beyond normal tools in our OS, Microsoft offers us another set of tools that we have available. Let's kind of talk through some of these. And these are all in Network Watcher. And I think they've moved these a bunch of times.
They always move them. I always have to go looking for them.
Yeah. So we're going to show you how to find them. We'll do a demo. It's weird because I think network watchers get created in every region where you've ever had a virtual network. So there is a network watcher in that region. However, you don't click on the individual network watcher to use these tools. You just search for network watcher and the tools are there. Yep. The tools used to be available, I think, within a VNet, right? Like it was in the context menu of the VNet.
Yep.
And that made all the more sense. But now they're just under network watchers. So
they moved our cheese.
Yeah. They moved our cheese for sure. So let's talk about some of these. John, you want to talk about IP flow verify? This is probably one of the more common ones I've used.
Yeah, and I agree. This is probably the more common one that I use, especially in Azure. And IP flow verify just verifies that IP traffic is getting from one endpoint to the other. So if I have two virtual machines, and maybe I've got two virtual machines and two different VNets, I want to be able to verify that VM1 can talk to VM2, and so that IP flow verifier just does that. It just verifies that IP traffic can flow from point A to point B. And you can go from, like I've gone from cloud to on-premise. So that's very handy, especially if you've got like a site-to-site VPN and you want to verify that your on-premise equipment can talk to the stuff in the cloud. You can actually use IP flow verify to verify that.
Yeah, in most of these tools are going to work across VPN connections. Yeah. Obviously, there's a tool called VPN troubleshooting. They may not be able to give you the same level of information in your
and really you only get back a success or failure.
Yeah.
Right. You don't get any other metadata or anything about the traffic. You just, it works or it doesn't.
Yeah.
It's better than nothing.
I think it's effective. The easiest tool to compare it to would be traceroute, I think, like that you use in a client OS, that you can see the route it goes through in the hops. The NSG diagnostic tool is pretty handy. We've talked about the differences between NSGs and firewalls, and NSGs are effectively like low-level firewalls that are only supported on the subnet and resource level. So these are ways we protect port traffic and block things. They're a little bit, they can be a little bit more challenging to implement than firewalls, because typically with firewalls, we're going to have clearly defined policies, whereas with NSGs, we don't have inherently a uniform way of managing them. Like we might want to define that in Bicep or code, Terraform, whatever, so that we have a consistent set of rules. But in a lot of cases, these are kind of managed by hand. So if we have complex sets of network security group rules, it can help us understand if we're getting blocked on one of those. I'm going to talk about NextHop a little bit because I've used this a lot. John and I were talking about third-party firewalls, and I'm kind of of the opinion that I really, really dislike third-party firewalls, but just about every enterprise customer I've ever worked with uses them. Because what happens is you have a group of network engineers. They're really comfortable with pick your network vendor, whether it be Cisco, FortiGate, Barracuda. Those are the three I know off the top of my head. They're really comfortable in that space, so they don't want to learn the like Azure firewall tools. So they'll use those tools. Those tools are more opaque, so it's harder to troubleshoot that traffic. So a lot of times you'll maybe want to see what the next hop is after it goes through the firewall, so you can identify what the traffic is, and you can see how a packet's getting from a VM to any destination. So here you specify the source VM, the source network adapter, the source IP, and a destination IP address. One thing we probably haven't talked about a lot is there are some scenarios where you might have multiple network cards on a VM to have different paths for different types of network traffic. It's not really common, but it is something you have available to you. John, do you want to talk about effective security rules a little bit?
Sure, and those are related to the NSGs. So it's kind of related to the NSG diagnostic where, as Joey mentioned, if you have a really complex set of network security groups, troubleshooting that can be really complicated because there's a multi-layer discovery or exploration that you have to do to kind of figure out what's blocking or allowing the traffic. So the effective security rules tool will basically show you all the NSG rules applied to a network interface. So you can look at that NSG to figure out, okay, these are all the rules that are applied, and maybe discover where that traffic is being blocked or being allowed. Maybe traffic's being allowed and you don't want it to. So the NSG rules will show you what the rules are in the NSG level. And I typically don't use the security rules a lot. I think I use the NSG diagnostics more so. But it's all related to the network security groups, which can get, again, sometimes it pulls your hair out.
Yeah, especially when like a customer is using a combination of a third-party firewall and or Azure Firewall and network security groups. Frankly, Azure Firewall doesn't work that differently than any of the third-party tools do. You configure the routing the same way. It's just the third-party tools with Azure Firewall, you can see everything right there in the portal. With the third-party tools, you have to like log into them, and especially from where we are is kind of, we do a lot of DBA work, but we tend to be like architectural consultants. We don't always have access to the network tooling, whereas if it's in Azure, we would see it. So that's probably the rationale for our frustration. I don't think I've used packet capture in Network Watcher. Most commonly, you're going to do packet capture when you just want to make sure traffic's coming through cleanly or you want to monitor performance. As long as you have a VM involved in this process and you're like using a tool like, say, Wireshark or any of those kinds of network packet capture tools, you can just capture those at the VM level. And as always, there will be additional overhead on your VM. But usually if you're running packet capture, that's kind of assumed.
I usually use a third-party packet capture.
Yeah. I think I've only ever used Wireshark for packet capture.
Wasn't sure we could say the name, but yeah, Wireshark.
Is it open source or is it like weirdly not paid?
I thought it was open source, but
yeah, it might be. It's all I've ever used. I mean, I don't know if there's any kind of packet capture in sysinternals too. That would be the one other set of tooling I've probably used in this space. If you're not familiar with sysinternals, that is a Microsoft-owned open source project. Mark Rusinovich, who's the CTO of Azure, originally wrote that. I don't know how much he has to do with it day to day anymore. But it's a whole lot of tools that do a whole lot of work on Windows and kind of beyond now, where you can get really, really detailed information. If you ever want to see how crazy Windows is as an operating system, just open up Process Manager on a running Windows box and watch everything happen. It's kind of insane.
There is a tool in sysinternals called TCP View.
Okay.
That shows you detailed listings of all TCP and UDP endpoints on your system. I don't know if that's the same as what Wireshark will do, but there's a PSP.
So that's probably like Netstat on steroids. When you actually need packet capture, it's pretty rare.
That's true. It's rare when you have to use Wireshark, but that's the one I use.
Yeah, I'm trying to, like, database scenarios, it's usually to make sure traffic's encrypted or something. I think that's about the only thing I've used it for. Or like you're trying to encrypt client traffic and you're having trouble. It's pretty rare that you're like looking for things in network packets. But then again, I don't work for the FBI.
Neither do I, thankfully.
Yeah. We also have a connection troubleshooting tool. This can be good, especially when you're troubleshooting connections under high load. It captures some information like latency in milliseconds, the number of probe packets sent. And if a connection is unsuccessful, it will tell you why, whether it's CPU, memory, guest firewall. I think that's where we've used this tool because I think when Denny and I were working at Microsoft, we ran into some issues with host-based firewalls burning us. It will also report DNS resolution, network security rules, and user-defined routes, causing blocking. So these are all pretty solid tools when you can't connect a VM to a VM. You can also specify an IP address. So in some cases, you can specify PaaS services if they're on private link. PaaS services here get tricky. We were talking a little bit about how For the most part, a lot of them use port 443 because they're HTTPS. I would say all of them do, except the ones that don't, which is very non-specific. Uh, like Azure SQL DB uses 1433, obviously. Uh, and even then, one of the things that can be confusing about PaaS services is their network stacks are a little bit different than they might be in the on-premises version. Like, um, I know both. We're probably most intimately familiar with SQL database and managed instance, and they
Yep.
both kind of have their own networking stack where you have traffic that passes through an application gateway before it actually gets to a database server. So you're never connecting directly to a database server. So it feels like you're connecting to a database server, but you aren't really. And have you used the VPN troubleshooting tool?
I have not.
I've used it a few
Not.
times. It's pretty solid. It's mainly around virtual network gateway connections, which is what we use to build a VPN, uh, and it'll run diagnostics on that to tell you if something's failing or not. Nothing too rocket science. And let's kind of dive in and take a look at some of these tools.
While you pull that up, oh yeah, your VPN.
My VPN's complete.
I was thinking though about these tools that this is a testament to, and I think we mentioned before in a previous video where, it's worth your while to just take a moment or a couple moments to plan out your Azure network and put some thought behind it in terms of how you lay out the VNets and the subnets and NSGs and all of that. Because maybe if you take that moment, you won't have to use these tools a lot. I have seen instances where there is no forethought in how things are laid out, and I have to use these tools all the time.
Yeah, and I think it's not just planning is very important, and John is absolutely correct there. I can't emphasize that enough. But I also think to an extent it's understanding what your network looks like.
Sure.
Most of the complexity, we've talked about third-party devices. Most of the complexity I see is around those third-party devices and cross-premises networking. It's not a big deal to do hybrid networking. We've got lots of customers that do it. Almost all of my customers have VPNs and have some, whether it be real data center or cloud presence, mixed. But you have to have common sense to it. I'm not going to name the customer that we've both worked with, but their mirroring would break all the time, and we would inherently know, the network broke again.
It's DNS.
Yeah. and having a reliable network where you know the patterns, you know exactly where potential bottlenecks are going to be is really important. And if you're a data professional, or even if you're just an Azure professional, that may not be your job, especially in a large organization. You may have a large network team. So it's important to just kind of understand that. And which brings me to the first tool I wanted to talk about here that we didn't even mention yet. It's called Topology.
Forgot about that. I have used that, and that's slick.
Yeah, and it's even though it has US East in the wrong place, US East is not in North Louisiana, or I guess that's Anthony Nosentino's house.
Yes.
East 2 is in the right place, but here we can see I have a VNet. I have other VNets in this region, I think. That was not helpful. But it will let me zoom in, and I can also zoom back out. Reset topology is what I wanted.
The other thing I like about that is that button right above that map that says download topology.
Yeah, you can download this, store it offline.
That's handy, especially if you want to send that to clients where hey, take a look at this or store this somewhere for reference later.
And so here we can see our peering. So this is where we have a hub and spokes. We see our spokes there. All that's pretty handy. We can drill into that network, and it'll show us, I think, the resources that are on the network. Yeah, so we see our various subnets, our firewall subnet, and we can drill into these VNets, and we see what subnets we have on them. Really kind of handy. I think that's in the VNet tools. Don't quote me on where all of these things are. Microsoft really likes to move things. We also have traffic analytics. This is a paid additional service that uses NSG flow logs to show you where your traffic is going. One of those enterprise things where you have to have control of your flows and want to see how things look. So let's use this tool. And I created a new SQL VM this morning. By the way, SQL 25 VMs are not available yet.
They will be at some point.
Yeah, they will be at some point. They're not yet. Okay, so we're going to select this SQL 1 VM and pick its network interface. And we're going to say outbound. And I don't know why it's not letting me select another VM, but one of these things about these tools is different incarnations of the tools will allow you to select VMs. Others will require IP addresses. Not a lot of rhyme or reason. So we'll grab the private IP of this DC. And these shouldn't be able to talk because they're not in peered networks. So we're going to say port 80, or we'll say 1433. And then here we'll say, and I don't remember my 80 ports, so we'll say 3389.
Which, for those that don't know, is the RDP port.
It's RDP port, yeah. So these networks shouldn't be able to talk.
So we'd expect a failure here.
No, maybe not. Maybe I dropped this into the infrastructure network. We'll find out. It's more like a surprise. Okay, so access was allowed. It's the same VNet. When I saw the IPs, I was like, that's got to be the same VNet.
Well, I didn't notice that. Yep.
Yeah, there we see it's within the same VNet, so those two things can talk to each other. Let's take a look at VPN troubleshooting now that we have one. And I'm going to say start troubleshooting. And I'll go ahead and select my my infrastructure VM, and I'll say start troubleshooting. Oh, I have to choose a storage container. Oh, there we go. East US. Don't do what I'm doing and just throw things in random storage accounts where you will forget about them later. I would like to thank Microsoft for the generous donation they give us every year as MVPs to give us Azure resources to let us show you things like this.
Yeah, I like all that.
Yeah.
It's nice having the ability to demo some of these things.
Yeah, Microsoft is pretty generous with the credits they give MVPs. I don't know that all MVPs get it. I know Azure and Data Platform and the Dev MVPs get it. So we're able to kind of show off and learn and play with a lot of these technologies, which is really helpful because I think we're able to provide a lot of feedback to the product teams. This takes a minute or two. There's nothing fast about anything with a VPN, by the way. So just keep that in mind when you're deploying things. Not that you should be deploying VPNs on a daily basis. If you are, you're probably doing something illegal. But when you're dealing with a VPN, just know it's faster than it used to be. It took about 30 minutes to deploy when I deployed a new one this morning. But it used to be like 90 minutes. But likewise, the troubleshooting is here. And this is going to be a really simple connection because I don't have anything on the other end of my gateway. I just have this VPN. But this will diagnose this and it will return us results when we're complete. The other thing we have that I don't think we talked about is this connection troubleshoot where we can specifically just look at a destination port on a VM. So this is also handy to see if we have TCP or ICMP connections, ICMP, not ICDP, connections to a VM. And these are our basic kind of diagnostic tests. Just know that you have all these tools available to you and troubleshooting. These aren't the answer to every troubleshooting problem. I'll just kind of talk a little bit, stop sharing here and talk a little bit about problems that I couldn't solve. Every now and then you have to go to support for some network issues because they have access to logs and they have access to routes that you just don't have. Yeah. And it can be frustrating because support is not always the best, as we know, and it takes a while maybe to get to a good engineer. Sometimes they'll leave you scripts and stuff that you can use yourself to troubleshoot. Sometimes you just have to go to them because you need to see what's going on. Like my all-time favorite was we had a customer, and I think I might have mentioned this in the private link show, where like Verizon started blocking access to a SQL database IP in South Africa. And we had to troubleshoot that. But yeah, so every now and then you'll have some random network thing. Generally speaking, within your own private networking, it works all fine. It's, I think like we always say, VMs are easy. When you're in just a VM world, everything just mainly just works. All that networking is pretty well defined. It's when you start to get out, or you can do things like global peering and cross tenant and cross subscription peering. And that tends to be where you start to get some problems, just because the layers of abstraction get more complex, and probably in all realistic chances, there's more space for IP overlap, which is one of the more common places we see network breakdowns in the cloud. Anything else?
Yeah. The only I was thinking while you were talking about support, like I was actually thinking like just yesterday, I obviously Joey and I are friends. We talk all the time. I had a networking problem yesterday that I had to think through. Like, I think it was very useful that I could just reach out to you and say, hey, help walk me through this to make sure I'm not smoking crack, right? So I was thinking about all the other, because support is slow, you're right. Like, but there's a SQL community on Slack that you can ask questions on, and even Azure Networking. Like Joey and I monitor that channel, and we'll be happy to help answer. Or I know you and I both follow Reddit.
Yeah, there's an Azure subreddit.
Azure subreddit, you can ask questions to see if you can get help if you get something, because it can get convoluted and get messy.
And sometimes it's just not obvious, and that's probably the hardest part about network troubleshoot. Like, to go back to our earlier discussion, if it's in your data center, you can have a tool like, you ever use a Fluke?
Yes.
Yeah. Flukes are awesome.
Yeah.
They're these like network and fiber troubleshooting tools that you can plug into your network and do diagnostics.
Yep.
We can't plug in a Fluke to Azure. Like
my one tip is do not go into your data center and randomly yank a cable. I actually, way back in a previous life at a former employer, we had an intern who walked up and unplugged the production SAN production SQL box out of the SAN switch.
I would argue that if multipathing was configured correctly,
I'm not going to argue that, but just don't randomly yank cables.
You can randomly yank one, and it should work. And if it doesn't, somebody designed something poorly.
Correct. I don't disagree with that.
More than one, you're going to have some problems.
Yep.
Yeah.
Yep. I don't disagree with that. Just my random tip: don't just yank cable.
Yeah. So our takeaway is go to Network Watcher. That's where all the good tools are, and don't yank random cables in the data center.
For sure.
All right. I hope you enjoyed this. Like and subscribe. Get ready for AZ700. John, anything else before we close?
Nope, not at all.
Cool. All right, have a good day, everyone.
Bye. See you next time.